When you think of the most valuable materials in the world, you probably picture diamond or gold. Gold is worth about $108 a gram, and diamonds can cost far more. But there's a material that could make both seem almost worthless by comparison. A material so powerful, it could change space travel forever, revolutionize energy storage, and even alter the course of civilization itself. And right now, it's the most elusive substance on Earth. It's called metallic hydrogen. Before we explore why it could change everything, let's first understand what metallic hydrogen actually is. Hydrogen, as you might remember from school, is the lightest and most abundant element in the universe. Under normal conditions, it's a gas. The same stuff you'd find in weather balloons or in hydrogen-powered cars. But scientists have theorized for nearly a century that if you squeeze hydrogen atoms under extreme pressure, more than 400 gigapascals, they might rearrange into a solid metal. That's about 3.5 million times the pressure of Earth's atmosphere. Why does this matter? Because when hydrogen turns metallic, its electrons are free to move, making it potentially the most powerful superconductor and energy store ever created. And is where things start to get exciting. Because if metallic hydrogen behaves as theory predicts, the possibilities are staggering. It could do two extraordinary things. One, superconductivity at room temperature. Superconductors carry electricity with zero resistance, but they usually only work at extremely low temperatures. Metallic hydrogen might do it at room temperature, allowing electricity to flow without loss. That means power grids with no wasted energy, maglev trains that run for decades without slowing down, and electronics far more efficient than anything we have today. 2. The ultimate rocket fuel. When metallic hydrogen returns to its normal state, it could release enormous amounts of energy, far more than chemical rocket fuel. We're talking about up to 10 times the efficiency of current propellants. That means rockets could escape Earth's gravity more easily, carry heavier payloads, and here's the big one, possibly take humans to Mars in weeks instead of months. And maybe, just maybe, carry us beyond the solar system within our lifetime. That's the theory. But has anyone ever actually seen metallic hydrogen? For decades, metallic hydrogen existed only in theory. Then, in January 2017, two Harvard scientists claimed they had finally created it. They used a diamond anvil, literally, two of the hardest substances on Earth, squeezing hydrogen gas until it gleamed like metal. But here's the twist. Before anyone could confirm the discovery, the sample disappeared. Some believe it simply reverted back to gas when the pressure eased. Others think it was never truly metallic hydrogen at all. It remains one of the most tantalizing maybe moments in modern physics. Now let's get to know, why is it so hard to make? The main problem is the staggering pressure required. Even Jupiter, the largest planet in our solar system, has metallic hydrogen only deep in its core. That's how extreme the conditions need to be. On Earth, scientists have to recreate those pressures inside machines no bigger than a coffee cup without destroying the equipment. And then there's stability. If metallic hydrogen is metastable, meaning it could remain metallic after the pressure is released, it could be stored and used. If it isn't, it will vanish the instant it's made, like Cinderella's carriage at midnight. But if we ever manage to overcome those challenges, the impact could be nothing short of world-changing. If we could produce metallic hydrogen in bulk, the world would change overnight. Room temperature superconductors, no wasted electricity, near-perfect energy efficiency, super-efficient rocket fuel, making deep space exploration practical, energy-dense storage, powering devices far beyond today's lithium-ion batteries. But with great power comes great risk. Such dense energy storage could be weaponized, making today's explosives look like firecrackers. And if manufacturing required huge, specialized facilities, control over metallic hydrogen could spark a new geopolitical arms race. Right now, nobody knows, because nobody has made it in usable quantities. But based on current high-pressure experiments, early production could cost billions of dollars per gram. That would make it even more expensive than antimatter, at least in the beginning. If we learned how to stabilize and mass produce it, the price could drop quickly, potentially making it accessible for large-scale use. Imagine this: maglev trains crossing continents in hours, smartphones that run for weeks on a single charge, or spacecraft accelerating like the ships in The Expanse, or even Iron Man's arc reactor. Metallic hydrogen could make science fiction into science fact. But just like in the movies, when you create something this powerful, you have to ask who controls it and what they'll do with it. Metallic hydrogen could be our gateway to a new technological era, or just another scientific curiosity too unstable to use. If we crack the code, it might spark the next space age, solve massive energy problems, and reshape entire industries. If we fail, it will remain a shimmering mystery, a reminder that some of nature's treasures are locked away behind forces too great for us to control. So maybe the real question is this: if we can make metallic hydrogen, should we rush to use it? History shows us something fascinating. Every time humanity unlocks a new form of energy — fire, steam, electricity, nuclear power — the world changes in ways nobody could have predicted. Sometimes those breakthroughs lifted civilizations to new heights. Other times, they introduced dangers we weren't ready to handle. Metallic hydrogen could be the next step on that ladder. The real question isn't just can we make it, but are we truly prepared for what comes after? And here's the thing: metallic hydrogen isn't the only exotic material that could reshape our future. Imagine antimatter power plants. Strange matter that could rewrite the laws of physics. Or even dark energy, the mysterious force pulling the universe apart. Each one carries possibilities just as wild, and risks just as great. If you'd like to keep exploring these mysteries and dive deeper into the future of science, technology, and discovery, make sure you subscribe to the MindCache. Because the more we learn together, the closer we get to turning today's science fiction into tomorrow's reality. Stay curious, because today's impossible, it is often just tomorrow's reality.